Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development jobs building Windows and web apps of the world's best companies as quickly as possible. So in this lesson, we're going to learn more about working with collections of objects. In the previous lesson, I demonstrated how to create a collection, an instance of a collection type. Noted how to make it from a generic type into a specific by providing it the type of data we should be working with. We looked at simple procedures like adding items to and removing items from the collections, how to sort and do simple things like that. But beyond indexing into it and getting an item back out, or beyond just ordering and simple procedures like that, what else can you do with a collection? Well, suppose that you needed to filter that list of, say, 1,000 different objects in a collection to only work with a subset of them that met a certain criteria. So this is made possible through a new innovation that was added back in Visual Basic 2005 called LINQ to Objects. So in this lesson, what I want to do is explain the rationale behind LINQ, language integrated query, and provide a few examples to get you started with LINQ in your applications to filter large collections of data. So as you can see, I have opened up Microsoft SQL Server, which is a database server product from Microsoft. If you're familiar with relational databases and querying data in tables using SQL, or the structured query language, you're undoubtedly familiar with selecting data from a database, like I've done on screen here, where I am actually selecting data from a database called AdventureWorks 2012. It's a sample database that's provided from Microsoft. And so this database contains literally dozens, if not hundreds, of tables, as you can see here, that you might find in a company. This is a fictitious company with lots of fictitious data, and it's great for practicing your SQL skills or to use as an example database whenever you're building applications, just to learn. Okay, and so here I've written a SQL statement that will choose products where the safety stock level is greater than 600 and the make flag is equal to 1. You can see that it brings back some, but not all, of the rows of data. If I were to select, for example, all of the rows from the production.product table, it would bring back 504 rows, as you can see here at the bottom. But by adding a where clause, in fact adding two where clauses and appending them together with the and keyword, I'm able to refine that to just a subset of that list, just 12 rows of data. And I might write this query to identify those products that would require me to start producing again in the near future. All right, this is just a fictitious example, but what I could also do is not only pull back all of the columns for a given table, and you can see it brings back quite a few columns, but what if I only needed a few columns for my specific purpose, like the product ID. I only need the product number to do a reorder, and then also the reorder point from our table. I could furthermore restrict the data or filter out the data to just that those columns and rows that fit my purposes. Okay, so I'm merely using this as an illustration of what LINQ does, which is really the topic of this lesson. When you think about it, working with a set of rows in tables, like we just saw here a moment ago, is similar to working with a collection, or rather a sequence of objects that are stored in memory. They're similar concepts. So some smart people at Microsoft ask, well, why can't we use a syntax just like this that people are already familiar with, this SQL-like syntax, in order to query objects within our collections? And so that's exactly what they came up with in the form of LINQ. It allows developers to use a syntax that they're probably already familiar with, at least to some degree, in order to run queries against entire collections of objects instead of just, as we see here, rows in a given table. Okay, so now I'm back to the computer that I've been using throughout this entire series. And what I want to do is copy a starting point project that I created into my projects directory so we can get started now. I've unzipped the source code that's associated with this lesson into my documents directory, and you can find the source code wherever you are currently watching this video and streaming it from, or from wherever you originally downloaded this video. So there should be a folder called Lesson 23. Inside of that, a before and after folder. In the before folder, there should be an Understanding LINQ solution folder, and I'm going to copy that, and I'm going to put it inside of my Visual Studio 2013 projects directory, and just paste it in like this. And now I'm going to open up Visual Studio and then click the Open Project link on the Start page and navigate to my Understanding LINQ directory and select the Understanding LINQ.sln. And there are two code files in this project, car.vb and module1.vb. So car.vb has the definition for a class called car, and then also an enum. You can see that we have make, model, and year as strings and integers. Sticker price is decimal, and then color is this enumeration that I created called car color. Car color can only be white, black, red, blue, or yellow. All right, and then in module1.vb, you can see that I created a collection initializer syntax to create instances of the car class and have set each instance with an initialized set of its properties. And then after I've created a list of cars called my cars, I'm just going to iterate through each of the cars and printing them to screen. And so when I run the application, I simply get a list of all of the cars that are in the My Cars collection, which is a list of type car. All right. So let's do something very simple to start off with. I want to write a LINQ statement that'll retrieve all the BMWs from this list. So just glancing at this data, I can see that we have 3 BMWs. So the code to accomplish that is the following. And then I'm going to change this for each my car in my cars. I'm going to change it to BMWs. So now we're iterating through just this subset using this LINQ statement. So let's run the application now. We only get 3 results listed to our console window. So again, LINQ stands for the Language Integrated Query, integrating query operators into the Visual Basic Programming Language. So notice how the query that I wrote looks very similar to SQL. The largest difference here is the select statement, which is at the very bottom instead of the top, like we would have seen in our transect SQL statement that we wrote at the very outset of this lesson. And at the very beginning, you see you set the result of the LINQ query to a collection of BMWs. And notice here that we're just using this implicit type declaration. We didn't define this BMWs as anything except whatever is returned from this LINQ query. We don't care. We're going to let the compiler figure out the actual data type. We'll talk about that more in just a moment. But here we're looking through each item in the BMWs collection and just bring it out the screen. The key here is the where clause, where we are looking for all cars where the make property is set to BMW. So hopefully it's evident what we're doing. We're selecting every car in the My Cars collection and adding it to the BMWs collection, which we then iterate through and print out to our console window. Great. What's more interesting is if we set our breakpoint in line number 17 and we start debugging. So we'll do that and we'll move a line or 2 in. And when I want to take a look at, for example, the type of the BMWs collection, as I scroll into it, notice that the type is just enumerable type. It doesn't seem like a very solid thing. It has these angle brackets next to it, and we can actually drill in and see each of the results. But in Visual Basic, it calls simply this enumerable type. So the real type is not easily ascertainable in Visual Basic. However, the type is known as an anonymous type because it has no name and no definition. The type is created dynamically at runtime as needed. So this gives you the flexibility to declaratively ask for whatever you need, and a type will be created for you via the implicit type declaration feature of Visual Basic, where we just dim BMWs and set it equal to something and let the compiler figure out what the actual type is. All right, so let's go ahead and deselect that and stop debugging the application. I want to continue looking at this from a pragmatic perspective. So instead of worrying about how it works internally, we're just going to go ahead and start learning some of the additional operators. For example, we can extend this statement that we just wrote. In fact, let me just copy this, and I'm going to paste it again here, and then comment out this one. And I'll add to this an and, where I'm going to set and my car, or rather, and car dot year equals 2010 to further refine our select statement. And so this time we only retrieve one item into our BMW's collection. All right, so you can accomplish almost exactly what you can accomplish in Transact SQL, like we saw earlier, where we're able to add additional where clauses just by using the and operator. Great. So as I demonstrated at the outset of this lesson, where we were looking at the Transact SQL syntax, I was able to not only filter out the number of rows, but I was also able to filter out the columns that were returned in the result. Well, you can do that in LINQ as well through a process called projection. So we're going to rely on Visual Basic's implicit type declaration to create an enumerable collection of projected types. Are they cars? Not exactly. We'll use three properties of car to create this new Frankenstein class, I guess you can say. What's the name of this new Frankenstein class that we've assembled together? Well, we don't know the name. It'll be determined by the compiler at compilation time, all right, dynamically. So we never have to worry about it. It'll just happen. So let me comment this out and show you what I mean. So here we go. We're going to create dim new cars equals from my car in my cars, where my car dot year is greater than 2009. I'm going to select or project out a new data type with the following properties, and we'll just use properties from our car to create this new Frankenstein, this new anonymous type. All right, so my car dot make, my car dot model, and my car dot year. Did you notice how I had to get rid of IntelliSense each time I hit the escape key on my keyboard, because it wanted to auto type out my cars. For some reason it didn't recognize this my car identifier here. But now what we're doing, we're not working with cars anymore. We're working with something that kind of resembles a car. It has some of the same properties, but it's a whole new data type. And so we're going to work with a collection of those. What's their type? Well, we don't really care. Again, using our implicit type declaration style of syntax in Visual Basic, we're just going to have a collection of objects with these properties. That's all we know, and that's all we need to know, and that's just fine. So now we're going to iterate through this collection of new cars and print them to screen. There's just two, but they're both older than 2010, and that's all we really wanted to accomplish there. All right, so that's the process of projection. A lot more we could say about that, but we're going to move on from here. All right, so let me comment this out. We can also perform other types of tasks like sorting the same way that we would do it in SQL. Something like this. So dim ordered cars equals from my car in my cars, order by my car dot year, select my car. And here we'll change this to ordered cars, like so, and then run our example. And you can see it goes from the oldest car to the newest car. All right, so 2008, 2009, 2010. Great. So in addition to this SQL style syntax, there's another way that we can harness the power of LINQ through a version of LINQ called the method syntax. It's actually, I prefer working with the method syntax over this style of SQL style syntax, this declarative syntax, because I'm already used to working with methods as a Visual Basic developer. So I'm going to create a version of all these queries, or some of them, using that method-based syntax. And some of this you'll find more familiar, more comfortable, and then some of it might be a little puzzling. So here I'm going to create that original query with BMWs. I'll name it something a little bit different. So dim underscore BMWs equals my cars, and I'll use the where method. And so now I need to tell it what's the clause for the where. So I'm going to pass it a mini function. So I'll explain this in just a moment. Function car.year equals 2010. And then I'm going to chain that together with another where method. And I'm going to give it another little mini function here. And set the make equal to BMW. So I should be grabbing all BMWs that were created in 2010. All right, take a look at that syntax closely. And then we'll iterate through the list of BMWs. You can see we just come back with 1. So this odd looking syntax right here that we pass into the where clause is known as a lambda expression. I don't want to explain much about lambda expressions. That's definitely a more advanced topic. However, think of it this way. It's a shortcut inline syntax that allows you to define a mini function. Okay, so here in line number 33, the where method allows us to pass this little mini function, a lambda expression, and we're telling it basically give us all the cars that match this condition, car.year equals 2010. So here's kind of the car, the method declaration. What's the name of that method? Well, we didn't give it a name, so that's one big difference. But we just want to give a car, so for every car in the my cars collection, return all those cars that match that condition, car.year equals 2010. And then the same thing is true here. This will return back a collection of cars, and using that collection of cars, we'll further whittle it down using this next where method, and we'll pass it a mini function. So given all cars that are returned back from this, then filter the list down even more where the car.make is BMW. And so the result of all that will be saved in this underscore BMW's collection, and we just simply iterate through it. There was only one item in there. Great. There's also a order by and order by descending method. So dim order cars equals my cars dot order by, and we'll give it the function car. So we want to order, given a car, each car in the my cars collection, I want you to order them by car.year. All right, so that's what this little lambda expression, this mini method is doing, or mini function. And then we'll do ordered cars, like so. All right, so it gives us in order from the oldest to the youngest, 2008, 2009, 2010. And there's also an order by descending method that will do the opposite, 2010 to 2008. Great. Let's comment that out. And then also the LINQ query syntax gives us some extension methods. And these are kind of, when you think of extension method, think methods that are bolted on the side of collections that weren't part of the original definition of a collection and all of its given properties, but have been added to that by LINQ. And so we can do something kind of neat like this. So dim sum, so I'm going to get a sum of all of the cars, and what are we going to use to determine the total value of all the cars on our car lot? Well, we'll type in another lambda expression, function car.sticker price. All right. And so here we can, let's comment this out, we can then print out the sum. So let's go ahead and console.writeLine total inventory value, And we'll do that, and then we'll format it like currency, and we'll pass in the sum like so. And so $250,000 worth of used cars on our car lot. So how do you know what to pass into one of these functions? Say, for example, you look at my cars and you find something that you want to use. Unfortunately, IntelliSense doesn't really help you out. I mean, you already have to know what a func is, F-U-N-C. Really where you're going to find the most benefit from this is by searching where in LINQ, something like this, and then looking at the correct MSDN article, like enumerable.where method, and kind of scurrying around for this. And you can see an example of it in use. And so here again, MSDN is extremely helpful when you're trying to learn how to use and how to really utilize the .NET framework, and especially in this case, LINQ and its extension methods and things of that nature, this method syntax. So I realized that some of the syntax might look foreign to you, and I hope I took the time to at least explain what it does so you can understand the basics and what we're trying to get to, even if you can't just off the top of your head now redo this whole lesson and you haven't just memorized it all. Hopefully this makes sense. You understand at least the thought process and what you can accomplish using LINQ queries within Visual Basic. Again, a new concept, but you'll see it often as you look at examples on MSDN and across the internet. So we're almost ready to wrap up. I believe we have one more lesson and then we'll be done. So you're almost there. Hang in there. We'll see you in the next lesson. Thank you.